Hello and welcome to another video lesson. In the previous lesson, we discussed classes and inheritance, and in this lecture, we're going to go over polymorphism. So what is polymorphism? Well, it's a core concept in object-oriented programming that allows objects to be treated as instances of their parent class rather than what their actual class is. So in C++, polymorphism enables you to call derived class methods, subclass methods, through a base class pointer or reference, leading to dynamic method resolution at runtime. So when I say pointer, we're not going to go over pointers for a couple weeks. So just think of reference when I say pointer for now. There's two types of polymorphism. There's compile time polymorphism, which is achieved using function overloading and operator overloading, and this is resolved during compile time. And you've already done something like this before. Think of when we made classes and we did a constructor and we did an overloaded constructor. And in one of the constructors, we didn't take any parameters, and in the other one, we did. And depending on whether or not the user or whether you program an instance of the variable with a parameter or without it is going to determine which of those two constructors is called. So that's one example of compile time polymorphism. Another example is the plus sign in C++, how the plus sign can be used to concatenate two strings together, but it can also be used to sum two integers together. So depending on the data types, this determines what the behavior of that operation is going to be. And that's an example of operation overloading. So we've already seen polymorphism to a degree. What we're going to focus on today is runtime polymorphism. So things that use virtual functions. Runtime polymorphism is also called late binding or dynamic polymorphism. And it's achieved using inheritance and, like I said, virtual functions, and it's resolved during runtime. So like I said, we're going to focus on runtime polymorphism, which is what most people refer to when they talk about polymorphism in C++. So this is the virtual functions keyword. So member function that is declared in a superclass using the keyword virtual and is overridden in derived class. So that's what a virtual function is. You signify that you are going to create a virtual function by using the virtual keyword. And this is going to be called during runtime and is dynamic by nature. And a vtable is created whenever you enact an instance of polymorphism. It supports dynamic polymorphism, so runtime polymorphism. It's a table of function pointers that allow the correct function to be called for a specific object depending on the object's type. So it's a table of addresses to functions, specific functions. A compiler uses a vtable to accomplish the dynamic dispatching of these various addresses to go to various and specific functions. So here's an example of a code that uses a virtual function. So virtual void make sound. So in this example, we have an animal class as our base class, and we have a dog and a cat subclass. So respectively, a dog and a cat subclass. So the class animal is a superclass of the two subclasses, dog and cat, and we wanted to create a virtual function called make sound. And depending on what type of object I get, that's going to determine whether this one here, void make sound woof, dog runs, or void make sound meow, cat runs. So depending on what type of argument is given, with whether that argument's object is a dog or cat, it's going to determine what the behavior is. So this is kind of interesting, right? You have this concept of a function that is, well, in this case, it's kind of a generic function. But using that keyword virtual means that when we recreate those same functions inside of their subclasses, we can define new behavior. We can define different behavior for them. And that's what you're seeing here. And this here is a virtual destructor. So this is going to clean up the derived objects. It's basically going to clear them from memory and free up that space. So virtual animal, the tilde is representative of a destructor. So we didn't cover these last time because C++ normally cleans these up for you. But here's an explicit definition in case you wanted to see the text dog destroyed or cat destroyed, which I think is incredibly dark. And then here's the program being implemented. So we create an animal pointer new dog object and an animal pointer new cat object. And remember, we're just going to say, we're going to refer to pointers as references in this example, a reference to a new dog, a reference to a new cat, because that's just easier for now. And in a couple of weeks, we'll get into it a little bit more deeply. And animal one is a dog. Its type is a dog. So this pointer to make sound outputs woof. And animal two is a cat. And so when we point to the make sound virtual function, it outputs meow. So this is dependent on what type of animal called the function, what object was used to call the function. And then afterward, we delete the animals. And then here's an example of what the output looks like. So woof and meow and dog destroyed, animal destroyed, cat destroyed. Let's look back at it. So delete animal one, delete animal two. So dog destroyed, animal destroyed, cat destroyed, animal destroyed. That's kind of interesting, right? Because we had an override, we had a destructor override to signal that we want to say cat is destroyed. But it also allowed the animal virtual function to be called too. So that's interesting to us at least. So that's pretty much it. I'm just looking through my notes to make sure that I've given you everything. Okay, some reasons to use polymorphism are that you want to have more reusable code. So it allows for code that works with objects of different classes through a common interface. Flexibility, extensibility, making it easier to extend a program because new derived classes can be added with minimal changes to existing code base. You have your superclass that contains all of these functions, and we just want to amend it, slightly for some sort of a subclass. That's why we have this general class animal, and then these subclasses of specific types of animals, because they are types of animals. So it makes sense, right? And so this allows us to reuse our code and remain flexible. And it's also good for the maintainability of your code because it reduces the need for complex if and else and switch statements to determine what type of object. Think about it. What this would look like if we just used conditional statements instead of virtual functions. It might be a little bit funky. It'll get a little bit too wordy. And then I'm looking some more. I'm trying to see if I have anything that we don't go over. I think that's it. You're welcome to ask any questions about this code or classes or polymorphism or destructors or anything that we went over this time. The only thing I think you're going to wait for is pointers. So this is going to conclude this video lesson about polymorphism. Thank you so much for listening and have a wonderful day.